Definitely have to change out all these bolts. Hey guys, welcome back. Took about 3 weeks off. My in-laws came here from Thailand, so that was really good to see them. Took time off from work, took time off from YouTube, but it's good to finally get back into things. Today's video not going to be about anything in particular. I just want to get that battery hooked up to the bus bar, change out those bolts in the battery on the cells, and I got a new torque wrench. I also want to hook up the comms and get it hooked up to the PC. So let's get started. GROWNEER. It is a digital torque wrench. It does Newton meters and inch pounds. Hey, check it out. User manual. And a nice array of bits. Got Torx, Allens, and our metric there. A swivel head, little screwdriver, Phillips, and an extension. And of course, the torque wrench itself. So with this guy, we got several different units of measure. We got kilograms per centimeter, Newton meters, which is what we typically use with batteries and such. And we have inch pounds. And we have foot pounds. So to program the torque setting, all you do is press the up and down arrow here for your desired value. In this case, we're doing Newton meters, and we want 8 Newton meters. So set it to 8, and we're ready to go. Let's try it out. Time for some open battery surgery. All right, so the first thing I'm going to do is remove this back bus bar so we can take our high voltage, our 48 volts, down to 24 volts on each side and make this battery safer to work on. It's kind of awkward working over this thing. I think I'm going to do one side at a time. Well, I mean like one side of the one row. You might be wondering why I'm even doing this. Well, I did a video where I tested these bolts, the serrated head versus these ones with the lock washer. And at 200 amps, these ones with the lock washer get to about 150 degrees. And these ones will only get to about 100 degrees, so they do a lot better in transferring current. Now, I haven't seen, most of the battery companies actually are sending out these ones. But if you ever get these ones with the lock washer, if you can, try not to use those on your battery cells. If you're running high amperage, for a typical battery like this, these high voltage batteries, it'll probably never even be an issue because you don't really pull a lot of amps off these batteries, especially when you have multiple batteries in parallel. But if your battery is going to be in a high vibration or mobile application, you might consider using these bolts with the lock washers because these do hold better in that type of environment. However, just be aware that they do garner more heat at high amps. Anything over about, I'd say 100 amps, they'll start to get pretty warm. I'll put a link to that testing video down below. Alright, here we go. Moment of truth. Let's see how this thing works out. Got it set to 8 Newton meters. Let's see what it does. Check it out. So as you apply pressure, it tracks. It should start letting me know when we're getting close. Oh. Right there it is, 8. Okay, we've done all the cells, all the bus bars. Now, the last one we need to do is the bridge bus bar. You want to always take extra care when doing the bridge bus bar. These are hard to get over the serrated heads, the bumps. So you end up pushing this all the way around. So you want to make sure it's all the way over there to start with. So you got plenty of counter room when you go to torque it. All right. Okay, before we button up the battery, we just want to make sure the BMS turns on and that we can see all 16 cells. BMS is on. It's a good sign. Go to the cell voltage, and we have all 16 cells present. So we're good to go. Whoever said the expansion channel in the garage floor had no purpose? 6 feet on the nose. Oh man. Pure copper, baby. Wonder how many strands that is. This is big stuff right here. So we're going to do a double crimp. So this die set comes with 2 sizes on the larger size dies. You're going to have the plus size and you're going to have the normal actual size. So we're going to start with the 2-aught plus, and then we're going to finish with the 2-aught. The reason we do that with these lugs, if I were to start in with the 2-aught and crimp it down, you're going to end up with a little burr. It ends up kind of bleeding out the sides here. If you start with a larger size, it won't be as tight, but you won't have the burrs. But once it's compressed a little bit, then you can go down to your actual 2-aught and finish the crimp. Now we're just holding it in there. I stripped a good amount this time, so it's a nice, huge surface. All right, so it's all the way down. You can see it's not a very sturdy crimp yet because we're not finished, but it's nice and clean. There's no burrs. A little bit of a shiner there, but it shouldn't be a big deal. Now we got our 2-aught in there, and this is where we're really going to bite down on it. See, it's starting to leak. Gotta be really careful with this thing. I don't know how long those O-rings are gonna last. Anyway, that is a really solid crimp right there. If you can see the indentation in there, see it says 2-aught? That means it's tight enough. Okay, so our first cable's done. There's the 2 ends. Very solid. We'll throw some heat shrink on this. Right there is good. Right beneath the flat part of the surface. This stuff is heavy duty. It takes a lot of heat. I like to start over here so it doesn't walk down the wire. Kind of work our way up. Give it a once over. Should be good. Now we can do the other side. This heat shrink is actually really nice. I like it. It has a adhesive in there that when it gets hot, it comes out. You can see it right there, that shiny part right there. And it really helps it to adhere to the wire. Man, it's so annoying. I just changed the O-rings on this thing. Man. No, I don't know if I can recommend. These are supposed to be good, a good brand, right? This is Temco. I don't know if I just beat on it too much in the past, or just maybe I didn't install the O-rings right. You never know with these things. Sometimes you get ones that last forever, sometimes they leak on you. Leaking like a sieve. There's our 2-aught plus. Man, I am so sick of these. Look at this. Complete trash. I gotta throw these out. I'm not screwing with these anymore. But I finished the crimp. If anybody can recommend me a good set of hydraulic crimpers, let me know. Now I gotta make sure I clean the lugs because I've got hydraulic fluid all over them. That's fine. Just push this. It's the sheathing. It slides. By the way, that flare right there, that flange, unlike the flat one, right? You can see the heat shrink is curved, basically conformed to that flange. So that helps to keep your heat shrink from shimmying down the wire. Unlike these ones, where it could just slide down. Okay, we're going to be removing this set of cables. This was the cable set that was used for the Seplos battery. It's got these Amphenol connectors. And we're going to replace it with our new set. Okay, now we're looking inside the Lynx power in bus bar. Before we work on the bus bar, we want to make sure the bus bar is actually de-energized. No voltage, so we're good to go. This little plastic retainer separates the positive, which goes on top of the fuse, and the negative that goes on the bottom. Okay, there's our old set. All right, so we can land our 5/16 negative lug first. Got our washer and lock washer. They give you, Victron gives you copper lock washers. It's really nice. Has a really good feel when you're torquing it down. Okay. All right, ready to hook up the battery. Okay, so I removed the parallel set of cables that I had going in between the batteries. Now we have an individual battery set going to each battery, to the bus bar. On the bottom I have the Yixiang version 2 battery, and on top this is the version 1 battery. I've already secured the cables to the version 2 battery on the bottom. Yes, you notice I am kind of crazy with fuses and breakers. I have a fuse on the terminal for each battery, and I have a fuse in the bus bar for each battery. So both ends of the cables are protected. Okay. Okay, nice and secure. All right. Fire up the inverters. Synchronize power on. Turn on our main breaker. So I can see both batteries here. I just want to make sure we got a draw from both batteries. Waiting for the AC to start up. The compressor has a delay, so takes about 3 minutes. Nice cool air, finally. All right, so each battery, the first battery is pulling 8.4 amps, and the second battery is pulling 5.49. So a little bit of an imbalance there, but at least both batteries are connected, and we're pulling juice. So let's check out the battery communications. Okay, so first I want to show you the physical connection, how the PC is actually connected to the batteries in parallel, and then we'll cover the software. So we have this RS485 to USB adapter. So just plugs into your USB port, then it has a RJ45 coming out of it, and it's going to the first battery. This is my master battery, and the dip switches are all in the down position. The master, all dips are down. Designates your master battery. And from there, you just daisy chain down to your next battery, and this is our slave number 1 battery here. And you can see the dip switch configuration for that. We got position 1 is up. That's it. And if you want to continue on, you just continue on to the next battery. It's really easy. So your PC connection can either be at the beginning of the chain, like it is, or I can move it down the bottom one and put it at the bottom of the chain, or at the end of the chain. It doesn't matter. You can literally just move things around until you get it to work. I didn't even have to read the manual. It's that easy. It's pretty flexible. All right, let's take a look at the software. So there's 2 modes of operation. There's parallel mode, which is mainly for monitoring. You cannot edit any settings of any BMS that you're connected to in the chain. And there's single mode, which allows you to edit the settings in the PC software when connecting to the master BMS. You can see that all the functions up here are disabled. That's because we're in parallel mode. And when you're in parallel mode, you're going to be able to see all your devices in parallel. So device 0 is our master. And we can see the voltage at 59.92, current 16.46 amps going out. We're at 77% state of charge. And then we can flip over to device 2, which is slave 1. And we can see that we have 83% state of charge on this battery. All right, so let me show you how we can connect the PC to one of the batteries in order to change the settings within the application here. Now, since this battery is the master battery, in order to be able to get into it, it has to be a slave. It doesn't matter what slave ID it is, it just has to be a slave. So what I like to do is just change the first dip and put it on position 1. So now it's slave 1. Now this battery down here is slave 1 as well, but I removed the COM cable. So you have to remove the COM cable, otherwise you get a conflict. So now if we disconnect and reconnect on our software, you'll see the parallel mode is now disabled, and now we have all our buttons up here. Now this is kind of inconvenient because you have to, disconnect your cables over here on your comms bus in order to communicate with your PC, and you have to change the ID of the battery that you want to communicate with. So it's actually better to just leave them configured in parallel. Don't change any dip settings. Instead of using the PC software, go ahead and use your BMS app instead. That way you can do any settings from the BMS app on your mobile device, and you can just continue to monitor without disruption on your PC. However, there is one feature you cannot do with the mobile device, the mobile app, which is updating the firmware. So if you want to update the firmware, you have to go up here and update the the fireware. I can't believe they haven't fixed this yet. The words they use. I don't know how they come up with this even. Spell check. Come on, guys, from spell check, please. So yeah, so if you want to update the firmware, you can do that through the PC software only. So I'm going to go ahead and connect this back to master. Put that dip, so all the dips are off. They're all in the down position. Plug this back in here. Put this one back here. Now if we reconnect, you can see we're back in parallel mode, and now we can see both batteries. If you have a bunch of batteries in parallel, right? And you want to figure out, what the dip setting should be for each battery. There is a manual that shows all the dip settings, but it's really quite easy. You can literally just start playing with the dip switches and you'll see it pop in. So like right now, my slave is on device 1, so right. Now I'm just gonna so I got dip position 1 is up and dip, and the rest are down. So I'm gonna put dip 1 up and dip 2 up. So we're 1 and 1. And watch what happens. Look, it popped in over here. Now it's number 7. So it's not gonna like screw anything up if you just start playing around with it. It's that easy. You can literally, I just figured it out by playing with the dip switches. So device ID 2, oh, it flipped over to 3. I must have been on the edge there. Yeah, okay, I flipped that one. We put that one down and the second one up. I think that's device ID 2. Yeah, there it is. So your third battery would be in that configuration. 1 down, 2 up, 3 down, and 4 down. So let's wheel over a fourth or third battery and connect that up. I'm not going to connect it to the bus, but we're just going to connect to the comms only. So I have a third battery here. We're going to connect the comms port only. I'm just doing comms only, no actual power. So now we have device 2 that was already configured. So now we got 0 is our master, 1 is the slave down here. So master, slave, and then this one down here is our third battery, and it's sitting at 70% because we're just storing this battery. We're not using it right now. That's pretty much it. It's pretty easy to figure out the dip settings. No manual necessary. Okay, so that was a sweet and short intro to comm settings. The JK makes it really easy, actually. But that's all I really got for this video. If you don't want to wait to my next video, check out this one right here. And thanks for watching, and I'll see you on the next one.